Bees are very important to our ecosystem as well as our agriculture, and this includes honeybees as well as wild bees. And both wild bees and honeybees are threatened by a range of factors that are causing reductions in their populations.
Our study aims to look at one of those threats, the spread and transmission of diseases. Many of our crops are pollinated by managed honeybees, and the way that we farm now through large monocultures, we need a lot of pollination in one place for a very short amount of time.
A large proportion of all of the hives in the US are migratory, which means that they spend the winter in a relatively warm place and then they're trucked around the country to act as pollinators of our crops. Migratory beekeeping may create a situation where bees are coming in contact with more types of diseases than they normally would because they travel and they interact with bees all over the continent.
Having so many honeybee hives from all over the United States in one place opens up the possibility for a lot of disease transmission.
In this manipulative experiment, we're asking, do migratory bee colonies carry more diseases than their stationary counterparts? And when they return, do they transmit those diseases to those stationary hives?
From here, anyway. Maybe not.
So the design of this experiment is comprised of two groups of honeybee colonies, a migratory group and a stationary group. Both groups will be tested for pathogens, and then the migratory group will be sent to California to pollinate almonds, while the stationary group will stay behind in North Carolina. After about a month, the migratory group will come back to North Carolina and both groups will again be tested. After the migratory colonies have returned from California back to North Carolina, we'll let them forage together with the stationary colonies for about a month. We'll then test the pathogen loads with both groups to see if disease has spread from the migratory colonies into the stationary colonies.
This is an important question because bees are big business. Roughly 10% of the total value of agriculture is due to pollination, and honeybees, managed honeybees, are a substantial fraction of that 10%. So there's a lot of money involved here, and that's also the human food supply.
Diseases in honeybees are monitored oftentimes by apiary inspection programs, but these programs are often underfunded and understaffed. Results from this experiment could provide policymakers with the evidence they need to better fund these inspection programs that would combat the spread of honeybee disease.